have a fraction. Today we are simplifying fractions. It might not be that easy, but let's start out easy. How would you simplify this fraction? Read. What about 5? From the numerator and the denominator. So what you're actually doing is you're factoring out a 5. What you're doing is you're saying, well, 15 is the same thing as 3 multiplied by 5. And you're saying 35 is the same thing as 7 multiplied by 5. And how do you multiply fractions? You multiply straight across. So what I could do is I could separate this to 3 sevenths multiplied by 5 fifths. And what's 5 fifths equal? 1. So when you say you're dividing out 5, this is what you're really doing. You're factoring it out, and it becomes a value of 1 that you cancel. So the reduced version would be 3 sevenths. Right? That's what we're doing. That's what we're doing. So your rules are you factor, then you can cancel. Only if it's something that factors out of both the top and the bottom. It has to be something that factors out. So our first example that we have is x squared plus 7x over x squared. So you cannot cancel x squareds. Because you will, yep. Yeah, like a big sucker. So what your rules, the order that you do this is you factor, and then if something factors out of the top and the bottom, then you can cancel it. So let's factor the numerator. How do you factor x squared plus 7x? GCF. All of our factoring rules are coming back. Like hardcore this chapter. Hardcore. No, hardcore factoring chapter. On the bottom, how do you factor x squared? X times x. Was there something that factored out of the top and out of the bottom? So then you can reduce it by canceling that. So now we have x plus 7 over x. Can I cancel those x's? Why can I not cancel the x's? No, not for real though. Why can I not? What did I not do to allow me to cancel this x with that x? I did not factor it out. So x plus 7 is not factorable. So you cannot cancel x plus 7 with an x. Well, actually it is factorable. You can factor out a 1. But that still won't allow, I mean, you can cancel out a 1, but you can do that all day long. But you can't cancel the x plus 7 or the x's. So what is our first step? First step. What's our first step? Well, is there a GCF? So let me go off what you're saying. Our first step is you need to factor the numerator and factor the denominator first. Okay. And GCF is our first step of factoring, but there isn't a GCF. So now we have a trinomial. Tim, how do you factor a trinomial? I'm sorry. We did like 2 whole chapters on factor. And you did pretty fast back then. Okay, so I'm going to give you a hint, and by the way, you don't get to pass on the question. So it's called guess and check, and you draw 2 parentheses, and you guess what goes there, and you boil that together. What would you guess, Tim? Plus and minus. And what multiplies together to give you a negative 12? What adds together to give you a negative 4? Which one's new? Okay, in the denominator. Emma, remember the denominator. Perfect. If you forget the rule of difference of squares, which is what Emma was going over, you could always rewrite this denominator as x squared plus 0x minus 4, and then do guess and check, where your outside and your inside would add up to be 0. You do it that way as well. Okay, so our first step is factoring. Now what we have to do, and you won't understand exactly why the very first time that we do this, but you get it if you pay attention to this class. What we have to do is we have to see if there are any domain restrictions if I were to graph this. And this is what we were doing in our homework last class. Remember we had asymptotes? Because when we have fractions, the denominator cannot equal 0. When we have fractions, the denominator cannot equal 0. So what we're going to do is we're going to spend a second, and we're going to set each factor equal to 0, or not equal to 0, I should say. X minus 2 cannot equal 0, and x plus 2 cannot equal 0. And then you're going to solve each of those for me. And you're going to say x cannot equal what number? 2. And over here, x cannot equal negative 2. So if I were to graph that, there would be an asymptote or some sort of jump in the graph at when x was positive 2 and where x was negative 2. There would be some sort of jump in the domain. So I'm going to talk about this being the domain restriction. So the first thing we did was factor. Second thing we did was domain restriction. And in your homework, you were writing the domain over and over again in the range, hopefully. If you didn't do it, go back and do that. The third thing we're going to do is cancel factors. Do any of them cancel? Did we factor the top, we factor the denominator. Are there any factors that we could reduce? Say it. The answer is yes. Which one? No, it has to be exactly the same. We cancel it. The factor is in a parenthesis. So yeah, what factor on top is same as one factor on the bottom? Yes, x plus 2. I'm going to cancel out with the x plus 2 on the bottom. Those are the same. We're going to reduce it down. So now we have x minus 6 over x minus 2. After you cancel stuff, now we have to recheck domain restrictions. Recheck domain restrictions. So right now, what can x not equal? You say x minus 2 cannot equal 0, so x cannot equal 2. Now this next thing that I'm going to write, you don't necessarily need to write. I'm just trying to write this next thing so you can see all of my work in one screen at the same time because I have to keep scrolling. So rewrite the original question real fast. It was x minus 6 and x plus 2 over x minus 2, x plus 2. And then we had x minus 6 over x minus 2. Okay, so what we're saying is we're saying when we reduce these equations, we're saying that this one is exactly the same as this one. That's what you're saying, right? That's what equal sign means. But these are equivalent. The problem is they're not exactly equivalent. When we look at our domain restrictions for this one, we could not plug in +2 and we could not plug in -2. But for this one, +2 was our only restriction. This is a difference between these two equations. Here, if I plugged in -2, what would this parenthesis down here become? If I put -2 right here, what would that parenthesis become? 0, and then this one would become like -4. That one would become -4 times 0. That would make this denominator 0. But if I put -2 in here, does my denominator become 0? No. These equations are exactly the same with the exception of this restriction. So when you put your final answer, if this is going to be your final answer, you're going to put your simplified version, your reduced version, but you're also going to have to include that x can be any number in this answer, except x also cannot equal -2. So what you have to do is you have to put any domain restriction that was a change from start to finish as an extra piece of information in your final answer. I have another way of explaining this to you. But then once you've seen me do it 5 times, you should be able to get it. But I've got another way of explaining it to you. You don't need to grab your calculator. I'll just do this real fast. You just watch once I pull it up. So what I'm doing is I'm going to type both equations in here. And then I'm going to go to the table. You don't have to do this with me, just watch. I'm going to go to the table. And you will see that at 2, both of the equations don't work. And at every number, they have like the exact same value. Except at -2. See, at -2, the equations are not the same. So I have to put that extra piece of information to say that these equations are exactly the same if you say to the red one that it also can't equal -2. You see how every single value, when I plug in x, gives you the same answer except for -2. That's why we have to include that as part of our answer. All right, so you'll see that a few more times today. Next. Yeah. Okay, next. The denominator, we need to factor. The numerator, we need to factor. Our first step is factor. Jessica, you have factor the denominator or start? Do you do 2 parentheses?
Wait, what's the denominator?
Oh, the numerator.
Oh.
Oh, were you talking about the denominator?
I thought you said denominator.
Oh, did I? Yeah. Oh, we got the denominator. All right, Jessica. So the denominator, what do you do? Put in parentheses?
Yeah.
Yeah, we got to group them when they're 4 terms. We're going to group them.
Oh wait.
Yeah, keep going.
Divide the first one by 2 and the x squared.
The GCF?
Yeah.
And what's my GCF for the second one?
2. No, 4. Yeah.
So we're going to divide out our GCF. We're going to have x squared, parentheses, 5x minus 3, and then we're going to have plus 4, parentheses 5x minus 3. And that is not factored all the way. Because there's a plus sign in between those two terms. It's not just factors right now. Aiden, do you remember what to do next from here? Yeah. So, in my previous step, I've got some stuff that's the same. Some stuff in front of the plus sign and stuff after the plus sign that's the same. What's the same? 5x minus 3. So that is my GCF that I now have to factor out. So now I have 5x minus 3 as my GCF. And then what's left over? X squared plus 4. Remember that is factored by grouping. And we spent a very long time on factoring. This is how math works. If you learn it, you have to commit it to long-term memory because it will keep coming back. No? Is somebody playing a trick on you? Or, yeah, if you did leave it in their bathroom, so they might have taken it already to the... So they might have taken it down to the main office. Well, if it's in the main office, it's going to be there. So I'd rather you stay here. And other than that, if somebody stole it, someone should not. All right, where were we? Oh, we have the bottom factor. So now we're going to go back to the top. We're going to factor the top. David, I started it for you. Just guess and check. It's going to go in the first and last front spot. What's minus? Got to equal 16. Yeah, and then if you multiply back together, we would get minus 4x squared plus 4x squared for the middle, which cancels out. That's not factored all the way. Got another step. Why is it not factored all the way? What can you factor further? Ellie? Well, we just did it. Right there. I got the last question. Ellie?
X squared minus 4.
Right, x squared minus 4 can become x minus 2 and x plus 2. That is a difference of squares. But x squared plus 4 is not a difference of squares. It does not factor further. These are all things that you've learned already that if you need a private lesson, well, you're going to have to come in. Because I will not reteach chapter 3 or 4. Or both. Yes, both chapters. So from here, after you factor, your next step is look at domain restriction. So you're going to set 5x minus 3 not equal to 0, and we'll solve that to see what x cannot equal to. 5x cannot equal 3, so x cannot equal 3/5. The other one, x squared plus 4 cannot equal 0. So x squared cannot equal -4. But then I square root it, and what happens? I get imaginary. So this is actually useless information because it can't equal an imaginary number. Of course it can't. Imaginary. So I don't even need the imaginary part. I only need the real number domain restriction. So you found your domain restriction. Now we can start canceling things. Anything on top and the bottom? Factor out and cancel? X squared plus 4. So we have x minus 2, x plus 2 left over. And then on the bottom we have 5x minus 3. So now we reevaluate our domain restriction. What's the domain restriction now? X cannot equal 3/5. Is that different than it was before? No. So you don't need to say anything extra other than this is the answer. Because they have the exact same domain restrictions, nothing changed. I mean, some imaginary numbers canceled out, but you wouldn't see those anyway because they're imaginary. All right. Next. Number 1. Read. What am I going to do first? Do you believe multiply?
Yeah.
No, we don't want to multiply. What's our first step to say that we wrote it down?
I wrote it down. Factor.
Okay, so factor actually means to unmultiply. So what we don't want to do is we don't want to multiply it back together. It'll make it harder for us. We need it factored. So now read. Can you tell me about this being factored?
I think the x plus 1 is canceled.
Oh, you're way ahead of me here. I'm talking about factoring where, you know, it's so it's in parentheses and stuff.
It's already simplified.
It's already factored?
Yeah.
It's already factored, okay. Alright, excellent. So that job's done. After the factoring step, I'm just going to ask you like the easiest question ever, but you're right. You're right, I got one for you. Okay. After you do the factoring, then what's our next step? We need to look at the domain restriction. So what can x not equal? You say x plus 1 cannot equal 0, so x cannot equal negative 1. X plus 3 cannot equal 0, so x cannot equal negative 3. Did my domain restriction. Carly, what's next? What am I canceling? Yep, do it. Hello? Yes, we know one. Okay, bye. They haven't. So now I have 2 over x plus 3. What's my next step? You gotta look at the domain restrictions again. So now I'm looking at my domain restriction. X cannot equal negative 3. Is that exactly the same as it's always been? No. What changed? What am I missing here? So that has to be part of my answer. There you go. Number 2. Duncan, what's the first step?
Factor.
Factor. Thank you. Is the top factor?
No.
No. Is the bottom factor?
Yes.
Can you have factor it?
Square root
What will I write?
X minus 4 and X plus 4.
Perfect. Jacob, what's next? Okay. Now to write out those domain restrictions, we say that x minus 4 cannot equal 0, so x cannot equal 4. X plus 4 cannot equal 0, so x cannot equal negative 4. Charlotte, what's next? Cancel out my x plus 4s. Can you tell me what I would have left over? So on top, when I cancel out that whole x minus 4, there is actually a multiplied by 1 anytime that you cancel everything out. So we do have just the x minus 4 in the denominator. Stuart, what's my next step? Okay, so right now I have x minus 4 does not equal 0, so x does not equal 4. Is that different?
Yes, ma'am.
Yep, so I need to put in what I don't already know by looking at this. I need to add in x cannot equal negative. It's really messy. I need to redo that. It's bothering me. All right, we're getting there. Next one. Number 3. You want me to call on you? Is that what you're talking about? You should hear how I got mine. He's not my son. You should hear how I talk to my son. That's cool. It depends what he does. Number 3, what's my first step here? Well, 4 I can factor. I can factor 4. 3 times 2. I don't know that that's going to help me. Can I cancel out those 2's? You can only cancel out things that factor out. And since nothing factors out, that can be canceled. This is already simplified. Done? Yeah, right. Number 4. Natalie, what's my first step? Factor what? What? Okay.
It'd be a positive 1 and then.
Okay, good. All right, do the other one. Factor the denominator. If you're understanding the order, you can slightly work a little bit ahead. Mark, you got your denominator for me?
Yeah.
You got it.
Plus 2 x minus 3.
Okay, so after you factor, Emma, what do we do next? Okay, so what can x not equal? Negative 2 or positive 3. David, what do I do next?
Cancel out the x minus 3.
Okay. And I have x plus 1 over x plus 2. So I think, what do I do now? He's talking about the domain restrictions. But what do I do for this one? What do I write? Does not equal what? Negative 2. So then what you said is what we do next. After you figure that one out, how are they different, if they are different? the x not equal to 3, so I need to put that as part of my answer. Alright, ready? Third page? Are you kidding? There's not even any plus signs in that question. Oh, it's like multiply? How do you multiply fraction? Oh, I didn't realize it said multiplication. How do you multiply fraction? How do you multiply fraction? How do you multiply fraction? Can't type it in your calculator. How do you multiply fraction? Straight across. You've already learned. How do you multiply fraction? Straight across. I know what he's talking about. Okay, you want to see how good I am at multiplying fractions with there? There you go. I multiplied them. Straight across.
Then you have. Now you got to add all of it.
No. How do you multiply x cubed by x to the 4? Add your exponent. We just did 2 chapters on this stuff. Well, only sadly if you don't know it yet. Then how do you multiply y times y to the 3rd? Y to the 4. On the bottom, 2 times 4 is 8. Then we have an x. Then we have a y squared times y, which is a y to the 3rd. Now, all of these are factors. There's no plus or minus sign, so every single operation in this is multiplication or division. So if it's on top, it can automatically just cancel with something on the bottom because everything is in factored form. I mean, I can write out x 7 times if I want, but I don't want to. So 56 divided by 8, just like reduce that, it's 7. What's x to the 7th divided by an x? X to the 6th on top? What's x to the 4th divided by x to the 3rd? Or y to the 4th divided by y to the 3rd? Why? Now, I forgot one of my steps. Before canceling things. Yeah, so my domain restrictions is what the variable cannot equal. So x itself cannot equal 0 because that would turn this whole thing into 0. Also, y cannot equal 0. So I forgot this domain restriction. Then we come over here to our simplified version after we canceled out some of this stuff. Now, when I look at my denominator is 1. So, do I have any numbers that can plug into 1 and make this denominator 0? No, this 1 is not going to all of a sudden change into 0. But there's a variable, it'd be different. So I don't have any domain restrictions on the simplified version. So that tells me something changed. Here it is, right, both of them, yeah. So after this, I would have, and I don't need to write the over 1, I was just explaining how it was over 1. You don't have to write that part. But after that, I would, put my little semicolon and do x does not equal 0, y does not equal 0. That's your answer. No, it is not at all. Next one. Oh, we're multiplying. Let's do it one step at a time. Yes, so we're going to do it one step at a time. So the first thing I'm going to do is factor. So we're going to factor 4 different locations. Top left corner. Top left corner. Factoring. Top left corner. How do you factor? Go. Oh, what is your first step of factoring? All right. GCF. Is there a GCF? 3x. So we're going to factor out our 3x. And we get 1 minus x. And we factor out that 3x. Okay? So if you check your GCF first, usually that helps you. The denominator of that first fraction is 3 terms, so that one, no GCF. We're going to do guess and check. We'll do x and x. It ends in a minus 5, so it's going to be 1 plus 1 minus. What number is going to make 5? Okay, but one of them's going to have to be negative. Negative 1, positive 5. Multiplied by. Over here, we've got x and x. One's going to be plus, one's going to be minus because there's a minus 20. Or x plus 5 and minus 4. Right? Okay. And then 3x is just 3 times x. I mean, that's pretty much accurate. 3 times x is 3x. Okay. Now I'm going to do the domain restriction. That's our whole set. I must start out again. So x cannot equal negative 5. X cannot equal 1. And over here, this is also a denominator. X cannot equal, if you're not sure how to figure it out, you set it equal to 0 and solve it. 0. All right, now I'm going to multiply these together. Are you ready for this? We're about to multiply them. We multiply fractions by multiplying straight across. There you go. I multiplied them. They're now one big fraction. We're not adding. There's no extra plus signs in there. We are squeezing them together. Multiplication is when things are next to each other. Okay? I mean, you can rewrite it. You can rewrite it if you want. But like, this is multiplication. You just multiply straight across. So now we've got one numerator and one denominator. Does anything cancel? Yes, that's one big fraction. That's what I was trying to explain. Hold on. There's two of you on two different plots, so I want to clarify everything. Do you see how this is 1 minus x and that's 1 x minus 1? Those are not the same. But, you know, you can factor out numbers. And if I were to factor out, instead of 3x, if I were to factor out a negative x from this original one here, if I were to factor out a negative 3x, what sign does that change this into? Changes it into negative. And when I take a negative 3x squared and I take out a negative 3x, this becomes positive. So now this is a negative 1, and so is that. This is a positive x, and so is that. So if you need to switch the signs, you have to factor out a negative number, which we've actually talked about when we were going over factoring the first time. So at that point, these can cancel. There is one more thing I can cancel. How am I going to get what back? Oh, so how do I make negative 3? How do I factor negative 3? This is a very good question. How do you factor negative 3? It's negative 1 times 3 times that. So I can cancel out the 3 and the x with the 3 and the x, but there still has to be a negative 1. Let's see what we have left over here. We have a negative 1, and we have an x minus 4 left over. Welcome to algebra 2. You cannot. You have a credit. What's on the bottom?
I say a lot more than you.
What's on the bottom? Well, there's a number. It's 1. So x1 is the only thing on the bottom. Do I have domain restrictions in my final answer?
No.
So does that change? So I need to include every single one of those as part of my answer. So then I just list x does not equal -5, x does not equal 1, and x does not equal 0. There we go. Done. We're almost done. You have to do the next one before you go. You have to do the next one.
Algebra 1 had one step, and now algebra 2 has.
Oh my god!
Alright, what is your first step? What is your first step? Yeah, you can look at everyone. So your first step is factor. Top left corner. X plus 3. 2. Sorry, don't say that. Make yourself up. X plus 2. How does that factor? It doesn't. Okay, underneath it, x cubed minus 27. So back in chapter 4, when we were factoring polynomials, you learned a new factoring thing that you had not done in algebra 1. And it was factoring perfect cubes. This x cubed, take away 27, is a perfect cube factoring. So you may have forgotten the formula since we haven't used it for a while. And if you ever forget the formula, I'm pretty sure you can find it on the internet. But right now, it would be a good idea to write down the formula. So the formula, when you have adding perfect cubes, you first cube root those and you write the cube root a plus b, whatever those numbers are, or variables. And then there's a second parenthesis where you take the a and you square it. You subtract a times b, and then you add b squared. We've done it before. Been a couple months. Well, you can be again. So, factoring that first denominator, we're going to have a parenthesis. What's going to be in that parenthesis? It goes from x cubed to what? X. And then what's the cube root of negative 27? Negative 3. So you write x minus 3. And then in the second parenthesis, the first term is you just square whatever's in that spot, so x squared. The last term you square what's in the second spot, so 9. And in the middle term, you do minus the 2 multiplied together, but that gives me 9 minus negative 3x, which becomes plus 3x. Because you minus negative 3x. And then another rule about this factoring is this part will never factor further. So you don't have to waste your time trying to factor that trinomial because it's not going to factor further, which is kind of convenient when you look ahead at our other part of the other fraction. So what is my domain restriction? X cannot equal 3. Then we multiply the two fractions together. There, multiply them together. Yeah, you didn't see my experiment. I multiply them together, and then what happened? Anything cancel? Any factors cancel? So now we have x plus 2 over x minus 3. And then we reevaluate our domain restriction. Here, x cannot equal 3. Is that different? No. Well, it's exactly the same, so you don't have to add on any extra information about our answer. Your assignment is in the book. You gotta come factored and ready to go because tomorrow we
And yeah, that's fun to the weather. They will pass out uniforms on Wednesday, they did practice. Also, track is canceled. Anyone else got the window?